Hello dear students. So after discussing about Thomson's model of atom, now the next model of atom is Rutherford's model of atom. So today we'll have a look on Rutherford's model of atom. Rutherford's model of atom, which is also known as nuclear model or planetary model of atom. Right? So as we have already seen that Thomson's model is totally based on imagination, was not having any experimental proof or experimental work done about this Thomson's model. So after accepting Thomson's model, still number of scientists were performing number of experiments to find out, or you can say to prove the validity of Thomson's model. In the same way, there was another scientist, Ernest Rutherford, who performed the gold foil alpha particle scattering experiment in the year 1911. So Ernest Rutherford performed the experiment which is known as alpha particle scattering experiment. So in his alpha particle scattering experiment, whatever results he got, the observations which he got were totally shocking. They were totally different as we were expecting on the basis of Thomson's model of atom. So first of all, you should know what is the Rutherford's alpha particle scattering experiment. So what Rutherford done? He took a source of alpha particle, some radioactive material which emits alpha particle, and now he passed the rays emitted from this alpha particle through a narrow lid or a narrow hole. So here he took the lead slit which converts this alpha particle, the rays of alpha particle, in the form of narrow beam, right? Then in front of this he put a gold foil, a very thin gold foil, and this gold foil was surrounded with a zinc sulfide screen. So as you already know that zinc sulfide is a substance which is having property of producing a glow whenever a charged particle hits on it. So what he observed, Rutherford observed, he found that most of the glow was just in front of the sheet and showing that most of the alpha particles are going straight. Very few or very less amount of glow was found, or you can say deflection was observed by small angles, and very few, means you can say rarest glow was obtained just in front of the gold foil, showing that very rare alpha particles are being deflected by the large angles, right? So this is what which he observed. That was the Rutherford's experiment. Now there are some questions about this experiment. First of all, you should know what is alpha particle. So what is an alpha particle? It is nothing, you can say an alpha particle is a helium nucleus. From helium atom, if you remove the 2 electrons, then the leftover helium nucleus is the alpha particle, which is having a charge of plus 2 units of positive charge, and which is having a mass of 4 units. So you can say it is a heavy particle having a charge of plus 2, right? Now you must be thinking, why alpha particles? We could have taken another charged particles, we could have taken electrons, or we could have taken protons or something like that. But why only alpha particles? Because as its mass is high, so it has large amount of kinetic energy, and alpha particles could penetrate through the foil. Right? So Rutherford has chosen alpha particles. Why alpha particles? Because these particles are having a high mass. Each alpha particle is having a mass of 4 unit, and because of its 4 unit mass, the kinetic energy of each alpha particle is very high, and due to that high kinetic energy, we can expect that these alpha particles will be penetrating through the gold foil, right? And the another query which comes here is, why only gold atom, or why only gold foil? As you know, gold is the most malleable material, or you can say most malleable metal, and because of its maximum malleability, it is possible to obtain the thinnest possible sheet of gold. The gold sheet which Rutherford has used here, it was having a thickness of 0.00006 centimeter. That was the thickness of the gold foil which Rutherford has used, and this could be possible only because of highest malleability of gold. No other metal is as much malleable as gold, so it's not possible to use any other metal. If instead of using gold, if Rutherford would have taken some other metal rather than gold, then what would happen? It would have happened that this kind of thin sheet was not possible there, and in that case alpha particles might not have penetrated through the foil, and the results which were observed by Rutherford there could not be observed, right? So these are some basic queries that arise about the Rutherford's experiment. So what Rutherford has done, he has used alpha particles and bombarded them over a very thin sheet of gold foil, right? And in this case, whatever he observed. So first, let's have a look about the observations of the Rutherford's experiment. If we talk about the observations were very shocking. They were found to be very different as expected on the basis of the Thomson's model. As you must be remembering that in case of Thomson model, it was assumed that the positive charge of the atom is diffused all over. What Rutherford was expecting, that when that positive charge is spread all over the atom, then what should have happened? That the alpha particles coming here must have been deflected by a large angle, and a very some good amount of alpha particles would have also been reflected back. This is what which was Rutherford expecting on the basis of Thomson's model. But contrary to that, whatever he has observed were totally different. Rutherford himself was very much shocked about that. About his experience, he has written in his book that the observations of the experiment were as shocking and surprising as somebody says that a 15-inch cannon shell is fired on a tissue paper and it is reflected by the tissue paper and hits you back. Right? You must be thinking, what is this impossible situation? Yes, this is the results of the experiments were also equally found to be impossible as this case, right? So whatever the observations Rutherford has got here, first of all, he has seen that most of the alpha particles went straight undeviated. So maximum number of alpha particles, they went straight, they went and deviated. There was no deflection observed from their path, right? And another thing what he has observed, that few alpha particles were deflected by small angles, right? And third observation which he got here, that very few, you can say 1 out of 20,000 alpha particles were deflected by very large angles. Right? So as you can see here, as most of the globe was localized in this area just behind the screen, it shows that most of the alpha particles are coming straight. They are not changing their path. It shows that they are not getting deflected here. Some globe was observed here. It shows that a few alpha particles were deflected by small angles, and very rarely some globe was observed here. This shows that very few. How many few? You can say at least 1 out of 20,000 alpha particles, they were deflected by the large angle. So you can say they were almost reflected by the gold foil. So based on these observations, Rutherford has drawn some conclusion. So if we look at the conclusion of Rutherford's model, as the first observation says that most of the alpha particles went undeviated, this could be possible only if most of the space in the atom is empty. Around, you can say 90% of the space of inside the atom is empty, right? Secondly, he has observed that few alpha particles were deflected by small angles, and alpha particles that are positively charged and quite heavy in mass. So they could be deflected only by the positively charged protons. The negatively charged electrons cannot attract and change the path of alpha particles, as the mass of electron is negligible as compared to the mass of alpha particles. So, a particle like electron having negligible mass, it cannot change the path of alpha particles. So, the path of alpha particles was changed only due to presence of positively charged protons, right? And as only few alpha particles were changing their path, that shows that the protons or the positive charge of the nucleus is present in a very small portion of the atom. So, the another point, another conclusion which Rutherford has got, that shows that the positive charge of atom is localized in a small portion in the center of atom, right? So, you can see now that this statement is totally different from whatever Thomson has said, because according to Thomson, the positive charge of the atom is diffused all over the atom. It is not localized in some area, but Rutherford's model has proved that this positive charge is not distributed all over, but it is localized in a very small region. And the another conclusion which he got from here, as very few rarest alpha particles were deflected by large angles, so it shows that most of the mass of atom is localized in a very small portion of atom. So, these are the three conclusions which Rutherford has got from his alpha particle scattering experiment. And on the basis of these conclusions and observations, whatever Rutherford has got, he has given a model of atom that is known as nuclear model of atom, or which is also known as planetary model of atom. So, if we look at the postulates of Rutherford's model of atom, so on this basis, whatever Rutherford has said, first of all, that an atom consists of a very small portion in the center, which is positively charged and called nucleus. As first time Rutherford has given the concept of nucleus, he has shown the existence of nucleus in the center of atom. That's why Rutherford's model is also known as a nuclear model of atom, right? And the another thing which he said, that most of the mass of atom is in its nucleus, right? So mass of the atom is because of its nucleus, or you can say nucleus contains almost all the mass of atom. And the another thing here is that electrons revolve around the nucleus in circular path. So according to Rutherford, that the center of an atom which contains all the positive charge, means protons of the atom are present in the center of atom, and that positively charged part of the atom is known as nucleus. And another thing which was told by Rutherford, that most of the mass of the atom resides in its nucleus, and the electrons, the negatively charged particles, they revolve around the nucleus in circular path. So you can say the structure of atom is almost same as that of our solar system. In the atom, in the center there is a nucleus which is positively charged, and around this nucleus the electrons revolved in some circular paths. Exactly in the same way as in our solar system, the sun is present at the center and the other planets are revolving around the sun. That's why the Rutherford's model is also known as planetary model. So whether you call it Rutherford's model or nuclear model or planetary model, and that was a very big achievement towards the study of structure of atoms, right? So if we look at the size of atom and size of nucleus, the size of nucleus is very, very small as compared to the size of atom. So you can say the size of atom is of the order of 10 raised to power minus 10 meter, whereas size of nucleus is of the order of 10 raised to power minus 15 meter. So you can imagine that as compared to the nucleus, the size of atom is very, very large, right? So as it is a very big achievement towards the study of structure of atom, still the problem was there. This model suffered with serious drawbacks also. The first most major drawback of Rutherford's model is that it could not explain the stability of atom. Rutherford's model could not explain the stability of atom. Why? Because at the same time there was another scientist named Clerk Maxwell who was studying the movement of charged particles. So Clerk Maxwell, who was studying the motion of charged particles, and he has seen that whenever there is a charged particle under accelerated motion, it continuously loses its energy. And here also in the atom, in the center nucleus and the electrons are the charged particle which are moving in circular paths. That's why their motion is an accelerated motion. And according to Clark's theory, This charged particle means electron, because of its accelerated motion, will keep on losing its energy, and very soon a time will come when electron will drop inside the nucleus. It will lose all its energy and it will drop inside the nucleus. As soon as the electron drops inside the nucleus existence is no more, right? So, according to Maxwell, this process is going to take a fraction of seconds time. That means we can say that an atom is stable only for a fraction of seconds of time. No, we know very well that atoms are quite stable. So, in the light of Maxwell theory, Rutherford's model could not explain the stability of atom. Maxwell theory is right. It was proven otherwise also. And on the other hand, existence of various kind of matter around us, it shows that atoms are very much stable. Then there was no explanation from Rutherford's side about the stability of atom. So the major drawback of Rutherford's model is that it could not explain the stability of atom. Secondly, it could not explain the distribution of electrons in circular path. As it was told by Rutherford that electrons revolve around the nucleus in circular paths. Fine. But if you think that around the nucleus there are infinite number of circular paths possible. There are so many number of circular paths possible. So can electron stay in any of these circular paths? Or there are some fixed defined circular paths in which electrons will revolve. No explanation was given for this problem also, right? He could not explain that what are the circular paths in which electron will be revolving, and is there any fixed number of electron that is permissible in a given path. About this kind of electronic distribution, nothing was told by Rutherford. So on the basis of these two facts, the Rutherford's model needed some improvement, and that improvement, we should not say that Rutherford's model is wrong. No. We can say that Thomson's model is wrong, 100% wrong. But Rutherford's model is not wrong, because it is only, you can say, incomplete. It is not giving you complete ideas, but whatever he has told, that was right. Because in the modern structure of atom, we also say that in the center of atom there is nucleus, and in around that the electrons are revolving, right? So you can say that model was incomplete but not wrong. So the model was further improved by Bohr, about which we will be discussing in our next lecture. Goodbye till then. Have a nice time.